Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. Tonight we're going to be trying to track the Artemis 1 Orion capsule in deep space. Now, unfortunately, I'm a little bit behind on setup. Took me a little bit longer to get my alignment stars going, but we should be in good shape now. So I'm going to focus the telescope and we'll get over to Orion if we possibly can. Okay, we've got the Batinov mask on there, so I can get some diffraction spikes to focus off of. That looks good there. Okay. Now I want to do one more star for focus, and let's see how this looks. Denebula. That was Regulus just now. Okay, that looks good. I'd say that's still in focus. Okay. Okay. Now, while I get the new version of NeoTracker fired up, I'm going to go ahead and do a 30-second 2x2 over here. Just make sure we're not getting any frosting on the CCD. We're going to verify that, and that'll be good. Okay, that looks acceptable. Pretty sure. I'll let it do the dark frame. Let's see what serial port I'm on. COM 9. Okay, it's gonna be COM 9. real-time JPL Horizons data. Okay. That looks good. Alright, so now I'm going to turn on autosave. Go to one by one. Binning. Okay, so we're going to do 30-second exposures. Let's go ahead and start the tracking. What the heck are you going that way for? Oh. Okay. Okay, little bug, but fixable. I see my error, I'm pretty sure. Alright. First time I've used the new Neo tracker. Okay, so this is JPL. It's going to, I suspect, 180 degrees different azimuth than what it should be doing. Okay. Column 9, Horizon's target Orion. So target. Now we're happy. Okay. Okay. Now we're pointing. Now we're pointing where I expected us to point. Okay. Yeah, I sometimes forget the LX200 Classic does not handle azimuth values in a sensible fashion. For the LX200 Classic, 0 degrees is not north, 0 degrees is south. 180 degrees is north, which is just the opposite of what it is in just about any other coordinate system. But that's just how it is. Okay, now we might be in the trees, so that's the next challenge. We may have to wait for it to rise out of the trees. Oh yeah, we are in some serious treeage here. That is all pine tree right there, I suspect. But that's okay. We will be patient, and we'll just wait for Orion to rise out of the trees. It's a very low target. Right now it's 16 degrees above the horizon and climbing. So it took an automatic dark frame that kills the hot pixels, gets rid of those. Go ahead and bring up the camera control window so you can see that. And now we wait. We wait and we see what we see. Good news, I think, kind of looking down the side of the telescope, I think we're pretty close to the top of the tree. So hopefully we won't have to wait too long. But that's just how it is for the moment. Alright, now I'm going to pull up the chat. I feel like I've been rushing trying to catch up to where I wanted to be on the setup process and get going. Yeah, flipped radians, Andrew. Yeah, it's that crazy coordinate system for the LX200. I don't know why they designed it that way. I guess it made sense for them, the engineers who built it, because it is designed to be set up in such a way that you're pointed due south and level at startup. And so the starting coordinates end up being 0 degrees this way instead of 180 degrees. Maybe that made sense for them when they were building it and testing it. To me, it's a bit silly, but that's how it is. Is that what Leo said? Circular logic is circular. What do you know? Okay, now the other thing I'm noticing, there's like at least 2 stars here. There's one right here. There's one right here. That's a hot pixel right here. Blue pixel there. Auto dark is not a perfect process. But if there's a couple of stars in the frame, I mean, one of them could be Orion, but more importantly, they're not really streaking that much, which I kind of expected. Orion at this point is not moving super fast, but it means that I may want to take a longer exposure so that I can try to better distinguish between, say, background stars when it rises out of the trees and Orion itself. Otherwise it's going to be tricky. So I'm going to abort that image and go to 1 minute exposures. Which is still going to be mostly obscured by tree at this point, but hopefully in a few minutes we'll be out of the tree. In a few minutes we'll also be into astronomical twilight, so that's the other challenge. We've got a race against time on how quickly this thing's going to rise versus how quickly we're going to start getting into twilight. So astronomical dawn is in about 10-11 minutes. We have nautical dawn about 27 minutes after that, 28 minutes after that. So we can fight through astronomical dawn, and I think we can get on it. I don't think that's going to stop us from seeing it. It's when you get into later into nautical dawn that you start to really run into problems. Nautical twilight is going to be much brighter. And I've put the telescope basically as far at the edge of my property. I'm at the road as possible to try to get away from the trees in the east as much as possible. East is not a favorable direction for me at my property. And when you have a target that's 16 degrees high, it's really challenging. So gonna do my best here. Let's see how the telescope is progressing. I mean, we just need it to come up a couple degrees, I'm pretty sure. So it's taking a new auto dark exposure. Okay. I'm gonna go turn off some lights on the house to try to improve things as well. See how this exposure looks. Yeah, we're in no better shape at the moment. Alright, we'll just be patient and hope for the best. Come on, if we could just get some gaps through the trees. Yeah, we might end up going into astronomical twilight, but I'm pretty darn confident that it will rise out of the tree before astronomical twilight is over. So, with the way Artemis's orbit is right now, it actually gets lower each morning. So today, being the first, is that fair to say? Yeah, the first day since it left Earth, really. Not counting launch day yesterday. This is the best it's going to get for now. However, that situation changes. That situation changes later, towards the end of the month, really into December, based on the predicted preliminary orbit, the sort of pre-launch orbit that was visible on JPL horizons. It should get better into December, in the first weekend of December or so. It really is more visible in theory, although I don't know how the moon's going to play into that. So we'll see. I guess it should be far from the moon at that time. I have to double check. But at least in terms of altitude, azimuth, and how that plays with Twilight and all that, it should be much better into once we get into December, shortly before it comes back, about a week before it comes back to Earth. Okay, I think we're starting to clear the tree a little bit, and I do see a star up there in the top right. Up here, we saw stars elsewhere in the frame earlier, but it's hard to say how they've moved because they've mostly been just blocked by trees occasionally. Get a chainsaw already. Yeah, no. Neighbor won't notice anything, right? Well, that's an empty lot anyway, and fortunately, I guess the bright side of Hurricane Ian was that it knocked down some of the trees in that lot. On the downside, one of those trees landed on my fence. So, did have to cut that up with a chainsaw. But, that's just how it is. No, arboreal filter, yes. No, unfortunately not. But we'll get there. I'm pretty sure we're getting close. So hang in there, guys. We'll be out of the tree soon, I'm pretty sure. Good news is, it seems like Neo Tracker, the new version I've put together for the LX200, is working in theory. Streaming real-time data from JPL to track Orion. So it's at least, the scope is at least responding how I expect, put it that way. We're at, I think, 18 degrees elevation now over the horizon. If we can just get ourselves another degree, pretty sure we'll be in good shape. And it's all going to come down to hoping we can find something here that is not moving, because we're directly tracking Orion. So Orion itself, the capsule, should not be moving in the frame. Stars should slowly be moving relative to the Orion capsule, but it is relatively slow. Let me look it up. Just look up the table and see what the current rates are. I'm going to manually look up here and see what the current rates are. Yeah, it's about right, about 10 arc seconds a minute, thereabouts. And that's going to be, what is that going to be? About 6 pixels at full resolution at 1 minute exposures. So stars should be little streaky things, and Orion should be a not so streaky thing. But the streaks should be fairly small, even with a minute-long exposure. Now we are starting to clear the tree. We can see more stars now, so we're getting there. We are getting there. The automatic gain control on the camera is not sure what to do with this, but it's saving the raw FITS files. So hopefully when I process it at the end of the day, it won't look so dramatically shifting in brightness from frame to frame. The question is, are one of these stars not a star? Are one of these stars actually Orion? If I can get a clean frame here, I can throw this over to astrometry.net and get a solution on it. That's interesting. And by interesting, I mean that might be a good sign here. Notice this star right here. What is that? That is not streaking like the others. One of these things is not like the others. One of these things does not belong. Well, maybe it does belong. Maybe that is Orion or The other thing is, like, this really bright one here. I can't tell. I guess that one is streaking, but it's so bright, it's a little hard to tell what that's doing, if that's moving or is that not moving. But I noticed this down here is not moving like the others. See, it moved, but the stars actually didn't move so much. The tracking... Sorry. The tracking here is going to be a little bit jerky because the LX200 Classic is fairly limited. It does not let me directly set drive rates. So... I'm thinking we've got it right here. I'm thinking we've got it right there. Let's see what happens on this next frame. And I might be tempted to well, I don't know if I want to turn off direct tracking. I do like direct tracking, but it's a little bit jerky. Sometimes it seems to be moving the scope with Orion, and sometimes it seems to not be moving the scope with Orion so much. Okay, let's see what happens here. Oh gosh, if we can just get clear of that tree for good, I'll be happy. But again, the automatic gain control is making a mess of things. Well, okay, that looks a little streaked, but I don't know. It'll be easier to see in time-lapse when we string all these pictures together. We are now officially entering astronomical twilight, so gradually the sky itself will begin to brighten. But we've got real good clearance in terms of signal-to-noise ratio on what we see here in frame. So I'm not too worried about that. Just want us to be gone from the trees. Okay, I think we're getting out of the tree for good, thank goodness. Yeah, it was up here at the top of the frame, but keep in mind with the telescope it inverts the image. It's actually flipped upside down from what's really going on there. So, I tell you guys, I am oh so tempted to so tempted to stop direct tracking and see what shakes loose. Could try auto guiding, but we are alt-azaline, so you're gonna get way bad field rotation if you do that. I thought field rotation wasn't gonna matter because I was gonna direct track Orion, which I'm still doing, but okay. So what I will start doing is I will start preparing to build miniature time lapses out of the pictures we're getting right now. That. Start preparing that process. Let's see if it shakes loose here. frame. Having trouble getting it to stack properly. To work on that later. It's not doing me any favors there. I think I do see differential motion, but it's in a very faint object right here. If I'm blinking the pictures together. The other tricky bit is Deep Sky Stacker is just being a pain in my tail and not acting right. So what I'm gonna do at this point is I'm going to, after this exposure, I'm going to stop the 1 minute exposures at 1x1 binning. We're going to go to 2x2 binning for increased sensitivity and just sacrifice some resolution in the color. Okay. Two binning. Start exposure. Okay, so grab these exposures. I'm just gonna grab what I've got. Hard to say. Hard to say. Maybe it's not that. It's going to take a dark frame. And what I'm tempted to do as well, tell you what, I'm going to go ahead and, as soon as this image is saved, I'm going to get that on astrometry.net and confirm we're pointed at the expected coordinates. Just make sure everything's good on that angle. truly, I guess I didn't even need to wait for the dark frame, but... Okay, get that uploaded. We're going to double check the coordinates that we're at. So right now, the coordinates I expect to be at. So that was about 40 minutes after the hour for that picture that I just uploaded. We're going to see where we're at with astrometry. Okay. Yeah, we're off. We're quite a bit off. So I'm going to stop Neo Tracker. We're gonna go do a manual here. I'm just gonna. Okay, fine. Let you do that. Okay, so I'm going to see where we're at with that. Okay, so I'm gonna. Parent. Okay. Negative 04. Okay. I just did a manual slew to what should be the correct coordinates. Okay. Let's get on it. Start this as a new run of exposures. Actually, I don't want to do 1 minute. Let's do 30 seconds. Okay, so hopefully if the go-to is accurate, we should now be on it. Yeah, the two little donuts in the middle are dust motes on the CCD. That'll be taken out in post by flat frame calibration. Okay, please work. Okay, we have an exposure. Now I'm going to upload that, confirm that we are now pointed at the expected coordinates. And if not, I can issue an offset. It's going to take a new dark frame. And here it comes. Okay, dark frame is in. So now we're not directly tracking Orion. Orion should move through the field of view over time as the scope just sits here tracking the stars. course, the other issue is I didn't really... Oh boy, I should do that. When I pulled up the coordinates manually, I didn't really give it my true coordinates. I gave it something close, but not quite. So now I'm going to give it my true coordinates more accurately, because a little bit of topocentric parallax may matter here. It doesn't really matter that much, apparently. It's very similar. Okay, I don't know why astrometry is having so hard a time solving that last image, but I gave it the non-auto dark frame image. Oh, there goes an unrelated satellite faintly through the field of view there. Come on, astrometry, figure it out. Let's get the one that has the dark frame put in. Maybe that'll help it. Okay, that one came in. Wait, what? Yeah, okay. Yeah, that's much better. We're much, much closer now to the true expected coordinates. Wait, are we seeing motion here? Am I missing the boat here? Okay, let me up. Okay, I put in the new run of images into Deep Sky Stacker. Might be missing out on all the fun just by looking at what's moving. Let's see what shakes loose here. Okay, these are not color images. Oh no, it's just the telescope drifting, I think. No. Why you do this to me? Once again, Deep Sky Stacker is having the worst time. It's just not able to stack these pictures. I don't know why. That's crazy. It hates you this morning. It really does hate me this morning. Yes. Okay, this was 2x2008. I'm going to try looking at the astrometrically solved image, pull up the exact coordinates that it was expected to be at that time, and see what is there. It's also worth mentioning that I'm doing all of this within the 8-inch LX200. If I need to go deeper with the 11-inch, we can do that at a later date, possibly when things are more favorably positioned. Okay. First of all, let's see, Fitz header. This was at 48 minutes after the hour. Okay. Get coordinates. Let's plug in the coordinates of Orion at 48 minutes after the hour. Okay, it was right there. So it's in frame. It should be near the middle. It's one of those things that it may come out with stacking with longer exposures, with well, not even with longer exposures, just putting frames together, it may start to appear. So I guess it's worth grabbing these guys. Let's sort this by type first of all. Just grab this run of images, time-lapse the heck out of it real quick without even aligning the images, and see if anything becomes more obvious. I would have liked to have aligned the images, but since Deep Sky Stacker's just refusing to cooperate for anything today, I'll fix that later, but for now... Ugh. Why did you do that to it? Really? I guess that's what we're gonna do. Okay. Oh, we had an airplane streak through at one point. That's fun. The other issue is it's so bright. Okay. So ultimately what I'll have to do is get flat fields in here. At least I know I'm pointed in the right location according to JPL Horizons. According to JPL Horizons, it's in frame, it's here, we're capturing it. The question just becomes, are we going deep enough to detect it? Which is a very open question at the moment. If I could just find some flat field frames I collected earlier, but they would have to be at 2x2 binning, which I don't always do. I don't always collect flat fields at 2x2. In fact, I dare say it's rare. I didn't want to open that with GIMP. No. Okay, fine. Yeah, that's... It answers that question anyway. That's not a 2x2 flat field. Oh, yuck. Okay. Also, not a 2x2 flat field. It's getting brighter and brighter out by the minute. We're almost into nautical twilight at this point. Yes, we're trying to track Artemis with a cool telescope. Very tricky target. After some technical difficulties, I've definitely put the scope on the right coordinates, and we're collecting images right now, but Artemis is either not exactly where JPL Horizons is predicting, or it is a very faint target, in which case I'm going to have to do some more calibration of these images to try to pull it out of the soup. So... a whole lot more light frames now, but each one gets brighter and brighter due to Twilight. I think at this point it's safe to say it's going to be too bright to pick anything out, pretty much. Of course, I say that, but really... I think that's true. Yeah. Okay, so what I'm gonna do now, I'm going to make another attempt here to try and get these darn things to align in Deep Sky Stacker. Okay, now I got them to align. Nice. Okay, finally. That part is solved. The next part I want to solve is the vignetting. That's why the corners look really dark, the center looks really bright. It's called vignetting. So I'm going to try to fix that by taking some calibration frames. Hang on a second. So at this point I'm going to shut the scope off and point it at my neighbor's garage door. But don't worry, no one's living there, so I'm not peeping on them. But it's a nice bright white target, and I need something to calibrate on quick. Okay, we've got a scope pointing towards that garage door now. Not ideal. Try to reposition it here, get a flatter sort of illumination. Okay. It's probably going to be better. Could crank that up, actually. We'll do 15 seconds on that. So I'm pointing at a very dark point of the pavement right now. Just trying to get a somewhat even illumination across the field of view to calibrate on. That'll let us take out some of that vignetting and the dust motes and everything else and make for better pictures. Okay. Because that will help as well. So I got some some flat frames, just a few to start with, but that should be enough to get going. these in as flat frames. We have our light frames, we have our flat frames. Make sure I've got all the light frames in place. No, that is not what I wanted. You went back and you did the stupid thing again. How? How did you do that? It's like, oh, only one frame will be stacked. Why? We just fixed this. I don't want to continue. Why are you doing this? Why are you doing this? Could be because I think that's what it was. I think it's because I was using the last light frame as reference frame, and there may be too much pollution from Twilight for it to even pick up the stars in that frame. Yeah, that's what it was. Okay, so now I've got some calibrated pictures in theory. Throw these into a time-lapse and hopefully be able to pick something out. No, that's a hot pixel. Okay, well, I'll put up the time lapse of what we got. fingers are numb trying to do this. It's very cold out here this morning. Okay. So there's one little bright pixel that's sort of squiggling around there near the middle. I'm pretty sure that's just a hot pixel that's moving with the drift of the telescope. Looking for anything else that moves in a consistent straight line relative to the other stars. And I'm just not quite seeing it. So what I'm going to do is I'm going to take the earliest frame where we had the least amount of twilight and throw that into up to astrometry.net, solve that image, and draw a circle around the coordinates we expected to see Artemis 1 at. I'm not using Photoshop IB McFly, I'm using SAO Image DS9, which is software designed to analyze astrometrically solved images. It's not Photoshop. It's an analysis tool. So let's see, Fitz header. So this was at 10:45 Universal Time and 49 seconds. So I'll call it 10:46. Ultimately, the solution will be to see if I can pull it out by astrometrically solving all the images and having my my time-lapsing software highlight the coordinates where it was expected to be and see if anything's in there or not across all the frames. Trying to see it in motion is going to be easier than seeing it in an individual frame. Yeah. See, I just don't see anything there at the expected coordinates. At least not definitively. You know, actually, no. I don't know. There's like a little bit of noise almost that seems to be maybe moving rapidly through the frames. Problem is this time lapse is really fast, and it's also skipping some frames because it couldn't get the... Again, Deep Sky Stacker couldn't get the stars to solve. Couldn't lock onto the stars in some of the frames. I think it's just residual hot pixel noise or something. Yeah, I'll keep playing with it. See if I can... pull something out. Let me do one more thing here, though. I'm gonna try... I want to try to make this time-lapse video one more time, but slow it way down. Playback frame rate's way too high. So let me regenerate the time-lapse video. Hard to say, folks. Hard to say. I think I'm gonna have to try to tackle this with the 11-inch. I think that's just all there is to it. So I'll just have to wait for better viewing conditions where I'm not fighting Twilight and fighting fighting the scope tonight. But like I said, I'll continue making attempts trying to get these things to stack properly where it actually keeps all the frames instead of dropping every other frame, because it can't get a lock on the stars. And then pass all of them through astrometry, get them all done up that way so that I can highlight the expected coordinates of Artemis 1 throughout the frames. And then we'll see what we see. So stay tuned. I'll post that on Twitter whenever I get the results. Alright, thanks for watching. Until next time, clear skies. And there will be a next time. We'll come back to this with the C11 when the viewing conditions are a little bit better.